In this chapter, we are going to be solving systems of equations. And altogether, we're going to look at three methods of solving a system of equations. So here in section 1, we'll be solving systems by the method of graphing. Then in section 2, we'll talk about the method of substitution. And in section 3, we'll talk about what some people call the method of addition and what other people call the method of elimination. So, solving systems of linear equations by graphing. And because this involves graphing equations, I hope you remember how that works. You should already know something about equations that have two variables in them, x and y, and how to graph an equation like that. But if you need to review that, that's covered in chapter 3 of your book. So now let's start with an example of just one equation with two variables in it, x minus y equals 2. Whether this equation is true or not depends on what numbers the x and the y stand for. And there are many possibilities. Can you think of some? Well, for instance, x could be 2 and y could be 0, because 2 minus 0 does equal 2. X could be 3 and y could be 1, because 3 minus 1 is equal to 2. So if we put in 3 for x and 1 for y, the equation is true. Can you think of some other possibilities? What's that? I can't hear you. Say it louder. Well, here are some that I came up with. X could be 4 and y could be 2. X could be 5 and y could be 3. X could be 18 and y could be 16, because 18 minus 16 equals 2. X could be 0 and y could be negative 2, because 0 minus negative 2 is equal to positive 2. X could be 5.5 and y could be 3.5, because 5.5 minus 3.5 equals 2. X could be negative 1 and y could be negative 3. Negative 1 minus negative 3 would be the same as negative 1 plus positive 3, and that would be 2. And we could sit here all day and keep thinking of possibilities. There's no end to the solutions that you can find. Okay, let's try another equation. How about y equals negative 2x plus 7? Let's find some solutions to this one. And the way it's arranged, a good way to find pairs of numbers that work would be to start by putting any number you want in for x, and then seeing what y has to be to go along with it. So if we put 0 in for x, y would have to be negative 2 times 0 plus 7. Well, that would just be 0 plus 7. That would be 7. So one possibility is that x could be 0 and y could be 7. Another possibility is that x could be 1 and y could be 5. Because if x is 1, we've got y equal to negative 2 times 1 plus 7, which does come out to equal 5. Can you find some other possibilities here? If you want to pause the video, you can. Try to come up with at least a couple more alternatives. Okay, here are some of the ones I came up with. X could be 2 and y could be 3, because negative 2 times 2 plus 7 does equal 3. X could be 3 and y could be 1. Negative 2 times 3 plus 7 equals 1. X could be 4 and y could be negative 1. Negative 2 times 4 plus 7 equals negative 1. X could be negative 1 and then y would be 9. Negative 2 times negative 1 would be positive 2 plus 7 would equal 9. X could be 1/2 and then y would be 6. Negative 2 times 1/2 would be negative 1 plus 7 would be 6. X could be 1.3 and then y would be negative 2 times 1.3 plus 7, which comes out to be 4.4. And we could go on. So we've looked at two equations separately. Now let's put them together. What is a solution to the system x minus y equals 2 and y equals negative 2x plus 7. That is, what pair of numbers satisfies both equations at the same time? What can x and y be so that x minus y is equal to 2 and at the same time y is equal to negative 2 times x plus 7? Well, remember the solutions we found to the first equation and the solutions we found to the second equation? Can you find any that appear on both lists? Any pair of numbers, x and y, that works in both of those equations? Oh, I see one. Do you see it? Yeah, the pair 3, 1 is on both lists. So that would be the solution to the system. If we want both equations to be true, that happens when x is 3 and y is 1. And that turns out to be the only time that happens. So the only way that both equations can be true at the same time is for x to be 3 and y to be 1. So that is the solution to the system. So let's stop and take a look at where we are. A system of equations is when you have two, or possibly more, but we'll stick with two equations considered together. And then solving the system means finding out how to make both equations true at the same time. What numbers have to go in place of the variables so that both equations are true? Now, I told you we were going to see in this chapter, not just today, but in the whole chapter, 3 different methods of solving a system of equations. But first, let's talk about how we can tell whether a particular pair of numbers is a solution or not. So in this example, the directions say, determine whether each ordered pair is a solution of the system of linear equations. That is, are both equations true when you put in the first number for x and the second number for y? The first number in a pair of numbers is always the x, and the second is always the y. So here we have this system of 2 equations, and first we're going to check and see if negative 3 is a solution to the system. So let's go through and try plugging in negative 3 for x and negative 3 for y in both equations and see whether they both work or not. So to check negative 3 to see whether or not it's a solution to the system, first equation, if we put negative 3 for x and negative 3 for y, is the equation true? Is 2 times negative 3 equal to 4 times negative 3 plus 6? Well, let's see. 2 times negative 3 would be negative 6. 4 times negative 3 would be negative 12. Is negative 6 equal to negative 12 plus positive 6? Yes. Yes, it is. Okay, so that works in the first equation. Now, what about the second equation? Is 2 times negative 3 minus negative 3 equal to negative 3? Well, let's see. 2 times negative 3 would be negative 6. Negative 6 minus a negative, that would be the same as plus a positive 3. So is that equal to negative 3? Yes. So negative 3 worked in both equations. So our answer is yes, that is a solution to that system. If it worked in one but not the other, the answer here would be no. It's got to work in both equations to be a solution to the system. Okay, now what about 0, 3? Is that a solution to the system? Let's check it in the first equation. If we put 0 in for x and 3 in for y, it looks like this. 2 times 3, remember we're putting 3 in for y, equals 4 times 0 plus 6. Now is that true? 2 times 3 would be 6. 4 times 0 would be 0. And is 6 equal to 0 plus 6? Yes. Okay, what about the second equation? If we put 0 into that for x and 3 for y, we have 2 times 0 minus 3 equals negative 3. Is that true? Well, 2 times 0 would be 0, and 0 minus 3, yes, that is equal to negative 3. So 0, 3 works in both equations, so it is a solution to the system. Now we're going to see that the most common thing that happens with a system of linear equations like this is when you have only one solution to the system. Most often, there's only one pair of numbers that works in both equations. But it can happen that you have multiple solutions. We saw that here. We saw more than one pair of numbers that works in the system, and actually there are other solutions, other pairs of numbers that also work. And it's also possible to have a system of equations with no solutions. So we'll see examples of all of those things. Now remember back when we came up with a solution to the system x minus y equals 2 and y equals negative 2x plus 7, just by finding a bunch of pairs of numbers that work in each equation and looking for one that works in both of those, a pair of numbers that was on both lists. That's kind of the trial and error approach, and that's not really a good method. It's not always going to work. When it does work, it might take you a long time. You might have to write out lots and lots of possibilities before you find one that works. So that's not really a method. That's why I called it method 0. It happened to work on that example we were looking at, but it's not, in general, a good way to find a solution to a system. So let's talk about some methods that do work. And in this section, we're looking at the method of graphing. So this is method number 1 for solving a system of equations. Instead of writing lots of solutions to each equation and looking for one that they have in common, we can show lots of solutions to each equation by drawing their graphs. After all, if you draw the graph of an equation, what you get is a line where all the points on the line correspond to the solutions to the equation. So every pair of numbers that works in the equation is represented by one of the points on that line. So if we've got two different lines for two different equations, we can just look for the point that's part of both lines. That is the point where the lines cross. So that's how the method of graphing is going to work. So I'm going to end this video here and come back in the next one, and I'll explain exactly how that works, and we'll look at some examples.